Hi everybody, it's Julie Hester, and I'm going to show you how to use vectors in C++ programming. In this video, I'm first going to compare vectors to arrays, and then I'm going to show you how to use vectors by declaring vectors and then accessing elements in the vectors. So let's first talk about arrays. We have arrays from the C language, and they have some limitations. First, once we create an array, we can't modify the number of elements in the array. And there are some situations where we might not know how large we need our array to be. Also, when we're working with an array, it has no idea how many elements it has, so we have to keep track of that separately. And if we do try to access an element outside of the array, then our program can crash, or we can modify memory that we shouldn't be modifying, or any number of problems. In C++, we have a vector class, and we can think of vectors as a smart array. Now, vectors are going to have the same data. Vectors are an object that's wrapped around a standard C array, but vectors can grow and shrink the array. Also, vectors have a number of functions. One, vectors can tell you how large they are. They know how many elements are stored inside of them. We can add and remove elements to the vector. And then we can retrieve elements several different ways. We can always use a subscript like we can with an array, but we can also ask the vector for things like the first element and the last element. And then finally, vectors allow us to have some error processing. So now if I try to access an element that doesn't exist, my vector object is going to throw an exception, and I can catch that exception and do error processing inside of my program instead of just crashing. So how are vectors and arrays alike? They both hold a sequence of elements. The elements are stored in contiguous memory locations. And we can use the array subscript operator, the square brackets, to retrieve elements. But vectors have added functionality because we can declare them without knowing the number of elements that we need. If our vector is full, it will automatically grow when an element is added. And we have functions for retrieving or modifying elements, as well as error processing. So now that we've compared vectors to array, let's talk about how we can work with vectors. And the first thing is we need to include the vector library in our code by using #include and vector at the top of our program. Vectors are part of the standard template library. And when we work with objects in the STL, they're built to accommodate different data types. So when we declare a vector, we need to include the data type inside of the angled brackets. And it looks something like this. Here, if I want to create a vector of 5 integers, I can say vector int, give the vector a name, and then in parentheses, the number of elements that I want in this vector. Likewise, if I wanted a string vector, I would put string in as the data type, and then the name of my vector and the number of elements. Now here are 3 basic ways we can create a vector. The simplest way is just to create an empty vector. So I can say vector int first. All I have done is indicate that this vector is an integer vector, and I've given it a name. So at this point, this vector has no data. It's just the container or wrapper around what can potentially become data once I add elements. Or when I create my vector, I can go ahead and create elements at that time by putting the number of elements inside parentheses. Or if I want to initialize these elements to a value at the time that I create them, this third vector has two parameters in the parentheses. It has a 20, 5, so this vector will create this vector will be created with 20 elements, and they will all be initialized to 5. Once we've created our vector, we'll want to access elements, and we could use the square brackets like we do with arrays, but it's better to use the @ function. And that allows us to be able to take advantage of the vector array processing. So here I have a vector with 5 doubles, and the vector is named prices. After I've created the vector, if I want to change the value of the first two elements, I can say prices.at and then in parentheses the subscript. Now just like arrays, my first subscript is 0. So when I say prices.at0, I'm referencing the first element in this vector. And then I can use the assignment operator and set that element to the value of 5.99. And then I can continue to assign values to other elements by changing that subscript that's inside the @ function, or the parameter to the @ function. So the second element would be prices.at parentheses 1. And I could continue so forth and so on with the 5 elements that are in this vector. Then, after the elements have values, if I wanted to see one of the values, I can also use the @ function. I just won't be assigning it to anything this time. I can say prices.at0, and that will retrieve the value of the very first element in this vector, and I'll see the value 5.99. A lot of times when we're working with either an array or a vector, we may want to access each element. So loops work well with this. And one nice thing about vectors is we can use the size function to tell our loop how many times to iterate. Here is a vector of 12 strings named month names. And when I created this vector, I set each of the 12 elements to a different string representing the name of a different month. Now, if I want to print the elements in this vector, I can use a simple for loop by using an iterator I for my subscript, and I want to execute this for loop as long as I is less than the vector name dot size. So if you think back to arrays, the first subscript of an array is 0, and the last subscript of an array is size minus 1. The same is true of vectors, so I want my loop to execute from 0 up to the value of size. Inside the for loop, then I just need to use the @ function, and I can use that iterator value I as my subscript so that I can see each of the values of these vectors. So that's a little bit of how you can create a vector, access elements in the vector, and a comparison of vectors to arrays.